Hello, this is for Project 3, the 2D wind tunnel simulation for Osbay, and I will be doing the 60 Hz frequency. So to start, you have to construct the wind tunnel. You open Fluid Flow Fluent, and set the geometry to 2D, and then open it. And then you have to set your units to inches, because that's what's given. And you can start your sketch of the tunnel. Alright, so you want to make this perpendicular. And that's the setting chamber, contraction area, the test section, expansion. I can add our dimensions for this. So this should be 15 inches. This is 24. And this should be 12. And the last one is 42 inches. Now we can set the angle of this to 3 degrees. Then the height of the test section is going to be 3 inches, as we're going to mirror it across the x-axis. And then do the same thing for the setting chamber, which is going to be 11 inches for being mirrored. Now we just have to mirror what we have. Okay. Unflip it. And now just make sure your constraints are correct. Finish drawing your tunnel. 8 is 22 inches, and this should be 6, 6 inches. Okay. Now we just have to generate the surface. Concept. Surface from sketches, hit apply, and then generate. And once that's ready, make sure to update your geometry. And you can close this and then move on to your mesh section. Once that is loaded, you can start naming your sections. This will be the walls, the inlet, and the outlet on the right. You can drop down, see your named sections, and now it's time to create the mesh. We're going to select our geometry and switch the method to triangles and generate. And that's not very specific, so we are going to update the element size to be smaller. And update it. And you can see that the triangles are much finer here. And you can go back and update your mesh before you move on to your setup. Once that is open and loaded, you are going to go to energy and turn your energy equations on. And then you're going to go change the model to K epsilon and enhance wall treatment and turn on pressure gradient effects and thermal effects. Now moving on to the boundary conditions. We have to set the inlet velocity, which in the handout only the test section velocity is given. So since I'm doing 60 Hertz frequency, you can plug that in and get 14.5622 meters per second for the test section velocity. And you can use A1 equals V1 to find to get the velocity in the inlet, what it would be there. And so use that formula given in the handout times 6/22 for the different heights, and you would end up with a velocity of 3.971509091. Hit apply, and you can close that out. With that done, we can initialize our test and run the calculation a random amount of times. And wait for that to process. Now for getting all of the different contours asked for in the project, static pressure, total pressure, dynamic pressure, and velocity, you go to contours, open that, and then select all your bodies, and then for static pressure, and then for dynamic pressure, 7 display. Next is total pressure, 7 display. And the last contour we have to get is the velocity contour. And this is the last contour. So we can close and start with the plots. And we have to plot along our center line. So we're going to create a new surface. And since we have to find the length of the center line in meters, we have to go back to the geometry. And use the change it to meters so everything is scaled correctly. And then just H10. So this would be 2.32587 meters. Copy that, and then it can be closed. And head back to the setup where we create our center line with paste the length that we got, create close, make sure it is along the center line we created, and then pressure, static pressure, and static pressure, plot that. It looks like this. Dynamic pressure looks like this. Total pressure, what else? And then just the velocity is the final thing we need. And then that's it. And then lastly, I'll just have to write the files. So since this is 60 Hertz, we can make graphs overlaid with 20, 40, and 60. And that is it. Thank you.